In the last section of E, we'll look at a last method to solve a quadratic equation. It's called the quadratic formula. And we're not going to derive it, but if you have a quadratic equation in the form ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it goes to the tune of Pop Goes the Weasel to help you remember it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's try to use that to solve each one of these quadratic equations. First one, 2x squared equals x plus 6. That's not in that standard form, so let's move it into the standard form by subtracting x and subtracting 6 from both sides. So now we know that a is equal to 2, b is negative 1, and c is negative 6. So x equals the opposite of b, that's positive 1, plus or minus the square root of b squared. So that's going to be negative 1 squared minus 4 times a, which is 2, times c, which is negative 6, all over 2 times 2. So let's simplify. That's 1 plus or minus, and inside the square root we have 1, and then be careful with the signs. Negative 4 times positive 2 times negative 6 is going to be positive 48, all over 4. Okay, so now we have 1 plus or minus the square root of 49 over 4, or 1 plus or minus 7 over 4. 1 minus 7 over 4 is negative 6 over 4, which reduces to negative 3/2. 1 plus 7 over 4 is 8 over 4, which is 2. So our solution set has two rational solutions, negative 3/2 and 2. The fact that we got rational solutions rather than ones that are either non-real or are those conjugate forms where we have to leave it in the square root form means that this one could have been factored. So maybe factoring might have been easier. All right, let's try b. b, x squared plus 2 is equal to 6x. Again, we need to move it into the standard form, subtract 6x from both sides, and our a is 1, b is negative 6, and c is positive 2. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, let's simplify that. 6 plus or minus the square root of 36 minus 8 over 2. 6 plus or minus, and then when we subtract, we're going to get 28 under the square root, all over 2. So we have 6 plus or minus, and simplify the square root first, 2 root 7, all over 2. And you can factor a 2 out from the numerator. That gives you 3 plus or minus the square root of 7 over 2. Cancel those factors of 2. And it looks like our solutions are 3 minus the square root of 7 and 3 plus the square root of 7. This one actually might have been easier to do by complete the square because a was 1 and the b was an even number. But you see, it's going to work out the same. The process of simplifying it is a little bit more involved when you use the quadratic formula. All right, let's take a look at c. c is already in standard form, but you're going to notice that one of the terms is missing. So we really have 2x squared plus 0x minus 7 is equal to 0. So a is 2, b is 0, and c is negative 7. So x equals the opposite of b, which is 0, plus or minus the square root of 0 squared minus 4 times the a value 2 times the c value negative 7, all over 2 times the a value. So we have 0, which we don't need to say, right? When we add it to or subtract from 0, we don't really need to put that 0. So we really have plus or minus the square root of, and negative 4 times 2 times negative 7 is a positive number. That'll be 42 over 4. And let's see if we have a perfect square contained within 42. I think we're going to, one second here, I think I've multiplied wrong. Sorry, it happens. 4 times 2 is 8, times 7 is 56. So we actually had 56 in the square root. 4 divides evenly into that. So if we simplify that square root, that's going to be 2 times the square root of 14 over 4. We can cancel factors with the 2 and the 4, and we'll have plus or minus the square root of 14 over 2. You can put that in solution set form if you want. Negative square root of 14 over 2, positive square root of 14 over 2 are our two solutions for that one. Last one of this type. X squared plus 5 is equal to 2x. And we're going to move it into standard form first. And identify A as 1, B is negative 2, and C is positive 5. So x equals the opposite of b, which is 2, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times the a. So now we have 2 plus or minus the square root of 4 minus 20, all over 2. That's 2 plus or minus the square root of negative 16 over 2, or 2 plus or minus 4i over 2. By the way, we can factor out a 2 from the numerator. That'll leave us with 1 plus or minus the square root of 2i, or 1 plus or minus 2i. And then we can cancel that factor of 2 with the denominator, so two solutions, 1 minus 2i and 1 plus 2i, non-real solutions. All right, it's your turn to try. Stop the video and try A. All right, this one yields two solutions, negative 4 plus the square root of 11 over 2 and negative 4 minus the square root of 11 over 2. This one requires a little bit of factoring to simplify, and then you have to remember simplify that square root before you try to factor the numerator and denominator and reduce. All right, now try B. This one produced rational solutions, 2/3 and negative 2. That's kind of an indication maybe we could have factored that one. Might have been a little bit easier in terms of the arithmetic and simplification involved. All right, now try C. All right, here's the solution for C. Make sure that you simplify the square root of negative 23 to I times the square root of positive 23. All right, last one, try D. All right, there's our solution for D. 2 plus or minus the square root of 5. This might have been an easier one to solve by completing the square. So let's wrap it up by looking at all four of our methods, comparing them. We've got the square root method, which you can use if b equals 0, or if you have an equation in the form something squared equals a number. Completing the square can be used for any quadratic equation, but it's easiest to use if you already have a 1 coefficient for the leading term, that is for the x squared term, and if b is even. It's easy to divide into two equal pieces. Factoring is a method that's fairly easy to use, and you should be used to it by now, but it's only good when the solutions are rational numbers, so it doesn't work for every single quadratic equation. Quadratic formula is a plug-and-play method, and we don't have to show a lot of steps, but you have to keep in mind negatives when you're computing the result, and it also results in sometimes more simplification steps if you could have used, for instance, completing the square instead or factoring instead. So that's just something to consider when you're considering which one to use. Different ones, it's easier to use one method over another. And that wraps it up for this section.